I'm Kevin Jones. I'm going to talk today about some things that I've been doing over the past few years. So as Mike said, I came in from NASA, and I'll have some stories from my days there. But particularly, one of the things that we did when I came in early on was solve a problem that we had as the solution architects, which is in public sector space, we don't always get access to network at client sites. And so if we want to bring our entire stack to show the customer our software, we actually have to bring it with us. And so we set out to solve that problem, and it led me to a bunch of the content that's in this presentation today, mostly around use cases and sort of considerations around edge computing and where we are today. And 4 years ago, edge computing wasn't being talked about that much, but driven by the 5G network race, edge is getting a lot of popularity. So first things first, about me, I am a developer actually by trade. So I spent about 15 years of my career as a developer mostly, but my curiosity led me to what I do now, which is I am a developer that plays an infrastructure guy at Red Hat. I was never satisfied with just writing code and then somebody telling me where to put that code and it execute. I wanted to understand how it executed. How do you optimize the things like web servers and databases? And then where that has led me now is the operating system itself and down to the physical hardware layer. And what I'm mostly specialized in these days is our cloud infrastructure products, OpenStack, OpenShift, Red Hat Virtualization. And so I spend a lot of time in customer data centers working on networking and things of that nature. I am also a father of these 3 kids, so Alexander, there, my daughter Mary, and my youngest one Riley, who is hilarious. I used to have hobbies other than technology, but now I just have kids. So there's that. All right, so I wanted to first, before I get into edge computing specifically, I wanted to talk about the relevancy of security these days and kind of put some numbers to it. The first one I'm going to talk about was 2017. There was a large credit reporting agency that lost about 150 million of their customers' data. This was due to a vulnerability in a piece of software they were running called Apache Struts. And the worst part about this breach was that they actually got notified, the leadership of this corporation got notified in 2016 by a government agency telling them that they had vulnerable software on the edge of their application layer, and their choice was to ignore it. And they left it running, and a year later, they have a $1.4 billion cost of that breach right there. I purposely didn't put names, but if you go Google, you will find these very quickly. You will also get really freaked out because the numbers are astronomical, and the amount of cases are astronomical too. The second one was 2018. This was not necessarily a security breach, but a security consequence, and also the combination of automation plus the consequence of downtime. So this is a large telecom provider. If you know anything about how the telecom providers work, there are several that are sort of the backbone of the network that we all live on, and then there's a bunch of other providers that also ride on top of that. In this case, this is a global telecom provider that forgot to rotate their TLS certs on half of their global network, and this caused less than half a day of downtime, and that $127 million cost is actually only from 2 of the smaller mobile providers that sued them for the downtime it cost them. So automatic rotations of certificates could have prevented $127 million worth of damage. The last one is 2019. This was now last year, but this is a large financial firm that also lost 100 million customers' information. This is a credit card company that lost us data. This was a situation where they started consuming a public cloud service that maybe they didn't understand, or maybe they didn't take the time to lay down a security baseline. In the end, they left in the object storage service, it's called a bucket, but they left a bucket with a significant amount of data publicly exposed. The worst part about this is that the way this was exposed was actually an engineer of the public cloud provider discovered that the bucket was vulnerable, and rather than notifying the customer, he chose to steal the data and sell it. So the cost on this one, the company is estimating 200 million, and the government agencies that are regulating and investigating are estimating $1 billion. All right, so another thing I want to talk about is just in general, like a lot of these things were manual tasks that were responsibility of a person, and those things can be very dangerous for us. This applies to edge computing as well, right? So the further we extend our digital landscape, the more critical this becomes because there aren't necessarily people always available at the locations that get deployed to. But in this case, this was actually a public cloud vendor themselves made a typo in a command that they ran. And that command, instead of taking down the small subset of servers that he thought he was taking down, took down a significant set of their regions. And this basically doubled on itself because now their throughput started decreasing as well. And this is about a $150 million typo just for the S&P 500 companies that are utilizing the services that went down. All right, there's another combination that makes this even harder is we have this astronomical sort of cost on downtime, human error, and the security that is inherent in all of the work that we do. But the other thing that's not happening is staff is not growing, nor getting more capable on average. And budgets are also decreasing. So I have a friend named Bill Hurst that draws this up. He used to draw this for his manager. So his manager would come in screaming about, we got to do more with less, more with less. And over a time period, what you actually see is you have more decreasing, 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 and eventually you just run out of less. There's no more less to take. So where we can actually complement this problem or start to solve this problem is using automation itself. So we can take automation and actually start to accomplish more with less. And the other thing we do is we're actually version controlling expertise. So in the case of the code base that I'll show towards the end, we have about 10 to 12 engineers at Red Hat that have contributed code to a code base we have to deploy our software stack. And our expertise, rather than being in our head, is in a GitHub repo on the public internet. All right, so now let's take sort of the need for security-minded approach and combining that with automation and talk about edge computing. So how many of you have edge use cases that you know about or think you're on the edge? So I would imagine everyone in this room has a mobile phone in their pocket and is using consumer services, be it Facebook, email, whatever, on that, which means you are an edge consumer by default. Now, in your day jobs, you may also have edge use cases. You may have remote offices that are being deployed to with no IT staff there, or you might have mobile work units, or you might have sensor networks that are being deployed out at scale. So this is where we get a nice little graphic here of what we're talking about. So I actually hate the term Internet of Things. I really hate that term, but it describes all the different types of devices that are being utilized today. My father was actually studying sensor networks, so the idea of combining a bunch of little dumb sensors that only know yes or no and taking that and aggregating the data out of what the sensors are saying so we can do things like detect flooding on riverbanks or detect the occurrences of earthquakes faster. Or another project he was working on is like dynamically using the sensors to control engine baffles in airplanes to dynamically control the sound of the engines. So all of these things we can combine, mobile phones, tablets, embedded systems, edge sensors. This is sort of that Internet of Things concept. We need to then take whatever data is being derived and calculate data off of that, derive data off of that. That's happening at these. This is what's really being deployed today is these sort of edge data processing centers. It may be a rack of compute on a tower, cell tower. It may be an actual small data center. It may be a central office. And then from there, you're sort of gatewaying data back to your cloud or on-prem data center. So this is conceptually what we're talking about. The other thing that's unique about edge computing is I've boiled this down to, I think, really two definitions of use cases. The one is where the source data is actually larger than the derived data. There's an example. I have a coworker who also runs a small sensor business on the side. He got contacted by Rwanda, and they are trying to protect their border. Now, the problem with their border is they don't have good coverage from a network standpoint, and so you can't stream video back from locations across our border. What you need to do instead is capture video data, do analytics at the site, and then send a small amount of data back that's useful. So you take an image or a video capture of 3 guys approaching the border with AKs, and instead of sending any stream back, which will never make it in time, you send a small text with GPS location, 3 guys with AKs, right? So we make some smart decisions about it. We derive a small subset of data. We send that over the small pipe we have, and we take action on it. That's the first case. That's like local analytics at the edge. You hear that a lot. Another example might be manufacturing. So I heard presented in Vancouver with a guy who was from a manufacturing company, and they had fabric coming off the manufacturing line, and they actually pay people to stand on very long shifts to watch the fabric as it rolls off. And they're there to detect error in the fabric. And instead, what they'd like to do is replace that with sensor capability that can actually pay attention for a 24-hour period, rolling the fabric through, and detect at a higher rate of accuracy than a human eye can. That's all source data, very important analytics right there, decision at the point of need. The other one is this centralized concept. So everybody probably has utility service, power, water, natural gas. You have meters that are reading your consumption of those services. The thing about that data is it's all text data basically, and it's very compressible. So the source data itself is just a bunch of text files essentially. They have very small pipe that they need to send that data back, but they calculate a lot of things off of that: consumption, need for repairs, your bills that they send to your house. And so the derived data actually is very much larger than the source itself. And so they do all their processing in the data center or in the cloud. So that's kind of the difference in the use case as far as how they are. The other thing you'll see is if you go Google on edge computing, you'll find that the majority of the presentations and talks and material on it is all about telco. It's all about the mobile networks, the 5G race that's happening right now. But the truth is, edge can be in any industry. There are significant demands for it. Some of the use cases that I'm going to go through today are really public sector focused because that's where I am. But in OpenStack Summit Vancouver, I got asked to speak on the Edge keynote stage because I was with that manufacturing guy, the only guy talking about non-telco use cases for edge computing at the time. The goals for us for an enterprise edge distributed architecture is really reducing latency itself. So not just like the actual latency on the networking, but like the time we needed a decision. So some use cases warrant that decision needed instantly, and we want to make that as fast as possible and get the end user or consumer of that data the answer as quick as possible. We do want to save bandwidth, so 5G is really pushing the limits of what we're going to be able to do, and things like Elon Musk's Skylink network are going to help tremendously. But the truth is, like, the network that is deployed across the globe in company intranets and stuff that have thousands and thousands of offices, the bandwidth itself is just being pushed to the limits at all times. So whatever we can save on there helps tremendously. Resiliency is another thing. So global services themselves, if you're providing service across many different countries or geolocations, then you need to be resilient with your application infrastructure. And so that's one of the major goals of edge computing, is to be able to distribute that locally out. You think of things like Netflix and streaming media, like we have to distribute that so that the consumers are getting it as fast and quickly as possible and consistently. The last one is data sovereignty. So the owners of the data care about where that data lives and how it's transmitted and where it's transmitted to. So if we can actually make a decision, do the analysis locally, and not have to transmit data across a wire, that could be beneficial from a security standpoint to be able to keep that data sovereign in place and being acted on as needed. All right, so now let's talk about a couple example use cases themselves. This is the big one I've been talking about for a bit in this, and this is the one you'll read most about. But the goal here really is to take what we have now and expand that so that everybody's getting 1 gigabit per second on their mobile devices. And a lot of us tend to go right to consumer phone services, but the truth is that all of the businesses we also rely on are reliant on these networks as well. And so maintaining operations and efficiency and taking advantage of the amount of devices that are coming online and providing network that can keep up with all of that is extremely important for global infrastructure, that we actually make this work. And one of the major limiting factors in 5G right now is that all of the telco providers are basically virtualizing all of their infrastructure. The vendors that have traditionally provided the boxes that were used for global infrastructure, these were like black box, proprietary, very expensive pieces of equipment. And what's happening now is they're taking commodity hardware, virtualizing those same pieces of equipment. But the vendors themselves, to do that, basically did the minimal amount of work possible to make that work. So a virtual router very much thinks it's still a physical router and it expects physical hardware, and it's making the race to 5G a little bit fragile right now because of the way you have to treat the infrastructure to make those virtual devices run. Now, if you combine that with containerization movement, and the industry, the telco industry, is pushing these vendors. I have a couple of terms up here, NFV and VNF. NFV is network function virtualization, so that's the effort to virtualize. VNF is an actual virtual network function, so a router, a switch, a firewall. And what is happening is the telcos are pushing these vendors to now go and containerize the things they've just taken a couple years to put in virtual machines. And the VNF vendors are significantly pushing back because it requires a significant amount of re-architecture to do that. The other thing that's happening is the actual container infrastructure. Kubernetes is the orchestrator of choice, has to have the capabilities to do the things that network services need. They're different than a web application, right? They need multiple network interfaces, and they need different things, different protocols to be enabled. So everybody's getting pushed by this race to 5G. From a goal standpoint, they want to increase speed for everybody. They want to, there's a term in this industry called minimized truck roll, and this is the idea that it's really costly actually to send a crew out in a truck to go fix something somewhere. So every bit of infrastructure that they can deploy, immutable devices out, they can be replaced in software. So everything they virtualize helps this goal of minimizing truck roll. This one is very common as well and has been around for a while, but it's getting more and more realistic now these days because the form factor of hardware is getting smaller and smaller, and the amount of compute and capability we can pack into a small footprint is getting dramatically improved. And this is kind of the one that led to the one I talked about as a solution architect. So we carry around, basically roll around a cloud that you'll see pictures of that can be carried onto a plane. And so the idea of throwing a kit like that, a cloud, in the back of a Humvee or in the belly of a submarine or in a tent in the desert in the Middle East, this is a real need. And the biggest thing here is you're sending these devices out with operators who are trained to use the applications that are deployed on them, but not necessarily IT engineers. So they need to be very, very easy to utilize. They need to be rebuildable. They need to be ruggedized so that they can withstand extreme environments. And they obviously have a huge security implications for their utilization, right? Because at the end of the day, what's on the line here is human lives, not just the service member themselves, but enemy lives and civilian lives are all dependent on this infrastructure that gets deployed out into these remote locations. This is another one that I came across at Red Hat. We send out, if you're not familiar, we do a bunch of certifications, and we send out instructors on location to do that training. And part of the value of that training is that we keep that content secure, only accessible by the students that pay for that and utilize that. It keeps the value of the certifications up. The other thing is our labs are all practical labs. So when you're when you're taking an exam, it's not a multiple choice exam. You're actually working on Red Hat software to get your certification. And so what we used to do is send out a bunch of laptops ahead of time, and then the instructor would have to arrive a couple days early, reprovision all the laptops, get it all set up, and what can be done actually is improve that situation tremendously. So we have a smaller form factor hardware that's available to us. They can basically roll that in person. People can bring their own devices, connect to the instructor's network, get access to the lab environment. You need multi-tenancy here so that one student can't affect the other student, and you need sovereignty on the data itself so that we know that nobody's stealing the content of the lab material or the test exam itself. And so this is a use case that we actually have at Red Hat. Many vendors do this, many organizations do on-location training where they have to carry and coordinate student resources so they have a good experience. The next one I'm going to talk about is cybersecurity, and I love like stock Google images of what cybersecurity looks like. It's always like some dude either in a hoodie with like a laptop with a bunch of stickers on it, or it's like the CSI type scene where they got like holographic, heads-up displays everywhere, and you could touch anything and drag it across. And the truth is, it's like government offices with like cubicles and like wires everywhere and crap hardware. And But what's interesting about this use case is that first of all, we're fighting a battle that's really difficult to fight. You have an unknown enemy. They have been working since they were kids. They have no rules defining their behavior at all. And we are fighting that basically with our hands tied behind our back because we actually follow rules and moral code. And the other thing is that we have to constantly build tools to be able to fight against the attacks that are coming constantly barraging all of our networks and devices. And so you have to build the tools on a known set of infrastructure that runs consistently. You have to then train on those tools on a known infrastructure that runs consistently and securely. And then the last thing is you have to send operators out into the field to deal with compromised situations, and they need to know that the tooling that they've been trained on and that has been developed is going to run consistently and the way they expect to in the environment. And the other thing is they basically have to carry disposable kits with them. So once you hook a toolkit into a compromised network, that toolkit is also compromised at this point. And so they actually need these things to be basically disposable. And so x86 hardware and the cost of hardware going down is actually significantly helping this use case. But we are definitely fighting a battle with our hands tied behind our back on this one. The last one I want to talk about is disaster response and recovery. This is not like DR in the data center, but actually like responding to natural disasters. So FEMA is the US organization that comes to mind when this happens, but the truth is there are many organizations that respond to a single disaster. There's a bunch of not-for-profits that are responding. There's also a civilian group called the Cajun Navy that's responding now. And so what has to happen is like the very first priority is consistent power. So when you send a unit out to respond to a disaster, you need to get power up as soon as possible. And so like FEMA basically sends semi-trucks out there geared up with their own generators to create their own power. The second thing they try to restore is network connectivity. So your cell towers are probably damaged. Network infrastructure in location is probably damaged, not good. And so you need to be able to stand up your own ad hoc networks and make your applications and your communications able to flow. And then the other thing is just coordination of all these different agencies. So you need to know how to respond, who's responding where, what areas are covered and what aren't. And so it's a very, very challenging situation to deal with. And so the other thing is just keeping the privacy of all those involved and all the data that's being passed back and forth to deal with this is incredibly important. For Katrina, as an example, the FEMA was actually in New Orleans for 5 years after Katrina. So you have to bring this there, establish your footprint, and then you have to stay for a while. This is actually Puerto Rico's most recent damage. in that image right there, but it's crazy. We actually sent a team, Red Hat actually sent a team out to the Bahamas recently to help just go stand up network capability across the Bahamas to help them get connectivity. And it's significantly challenging and dangerous work as well. All right, so from a consideration standpoint of security, you have physical security of the environments themselves. So when you talk about the 5G, so they're placing these compute capabilities out on the edge, either on the towers themselves or in small data center facilities. And these are not necessarily manned by people, so you need perimeter security around them. You need to be streaming video and surveillance of the environments themselves. You need multi-level access so that if you get into the building, into the door, you can't necessarily get to the racks of equipment very easily. The other thing is sort of logical security on the devices. So we want to have encryption everywhere, in transit and in rest on the devices themselves. Preferably, we'd like the devices to be immutable or at least have hardware attestation so that we can determine whether the devices have been tampered with when they boot up. So these are kind of things we were talking about. Back to that security where the network went down because they didn't rotate certs, right? We want to deal with all of that so our services don't go down on the devices because we forgot to rotate certs. There's a guy that works for us named Luke Hines. I thought this was pretty cool. So this is, if you haven't seen Ansible Playbook, I'm sure you have in the presentations earlier or you've seen one before. This is actually some of his code to take advantage of TPM chips. And he actually wrote an Ansible role that will deploy a TPM simulator. So if you don't have a TPM chip to actually play with, you can actually spin up his simulator and utilize it. But you can do all kinds of things with TPMs to guarantee the security and capabilities of hardware in combination with the software that's deployed. It's pretty neat stuff. And because of things like tools like Ansible, we can actually automate utilization of those things. This is certificate rotation, so there's modules out there for doing, this is Let's Encrypt stuff, but the idea of actually going out, requesting a cert be generated, and then applying that cert, and you could also automate the rotation of those certs as well. Just a sample of what that looks like in Ansible. I have sources on these. I think they'll be sent out, but there are source links to the material behind them. This next piece is really consideration down to the workload. So I talked about the data itself, sort of the sourced versus derived data. But more than that, you have to think about the services you consume for each of these, each of the workloads that you sort of put out there. So there's a ton of public cloud capabilities that are out there now. A lot of those are globally distributed. But I was telling a story even about if you're a global organization. So I have a friend who does global infrastructure for a small financial startup, and he was telling me they use AWS for almost everything, but there are certain countries and jurisdictions that don't even allow access to AWS APIs. And so they can't utilize that infrastructure in those locations. And so you have to really consider, based on your use cases, based on the locations you're in, what services are going to be available to you. And then once you choose services to consume, you need to understand how the service works, how its security layers are consumed and utilized. You basically need to build a security baseline for that service. And then you have to create something that's constantly scanning that service to make sure everybody's following that baseline consistently. So in the case of that public bucket that exposed all those credit card consumers' data, like they could have had, that's a case where they started consuming a service that they didn't fully understand and they didn't consistently lay down a baseline. So they could have been scanning their AWS accounts for buckets, pulling those back, checking the policy that was applied on those buckets against the baseline that they've defined as acceptable use inside of their organization, and they probably could have prevented that breach, right? So this is just to call out the fact that you will have to make choices about cloud services that you consume versus actual local services that you put on the box, and maybe some combination of those. This is just a sample playbook. Those links on the last slide were all to Ansible modules that deal with different cloud infrastructure and different on-prem infrastructure. This is just an example of using IAM, which is AWS's Identity Access Management, to deal with permissions for users themselves, right? So rather than somebody hand jamming through the interface, IAM interface, you can actually write this in version controllable code that can be committed. And there's all kinds of mechanisms to deal with the passwords and security of the credentials themselves. But you get the idea, be able to lay down a baseline in code that's version controllable. This is the same thing, but on an OpenStack environment. So OpenStack is an on-prem cloud infrastructure that has APIs we can utilize. Same thing here, an identity service. I'm giving myself admin permission and taking it away from my buddy Chris Reynolds. I don't want him touching my cloud anymore. So, the other thing is not to think just about the server footprint, but all of your footprint. So your network infrastructure as well. So your routers, your switches. Chris Grimm was up here talking about, not having telnet enabled on your network gear. That's doable too, right? So you should consider all of the server footprint you have, Windows, Linux, whatever it may be, but also your network devices. You should start laying down automation and security baseline for all of your network devices as well, and then you can version control that. So you have a source of truth for your network infrastructure that's in version control. This is just a sample playbook of going to a switch and just configuring a couple ports on the switch, but all of this is automatable at this point, and there's been significant work over the last 2 years to really increase the capability and footprint of network devices that can be managed and maintained. And at the end of the day, if you can connect to the device and run a raw command, you can still manage it, which is really cool. So at Red Hat, we actually, not only my use case, which I talked about early on, but we actually have a real true pure edge use case that weighs 85,000 pounds. So we've been sending this truck around the country for the last almost 2 years. And it travels through US and Canada. It's been to 44 states. And this thing is really awesome. So the idea was we actually bring Red Hat Summit to the customer bases that don't get to go there in person. And so we can configure this truck in many different ways. It can be like a Red Hat Summit type expo booth where there's demo stands and presentations. We can do workshops inside the truck. We can fit 40 students in the back of that thing. We can do executive briefings inside of the truck. And the thing about this truck is, like, I was part of the team that worked on this. So I had no idea actually how much it would take to make this thing work consistently. So one of the things we needed as an absolute minimum on the truck is uplink everywhere we went. And that is really inconsistent. In some locations, you're getting less than a megabit per second. Some locations, you're getting 40, 50, and you can push it. But you got 40 students in the truck pulling down a bunch of content because the architect on there didn't think about the fact that they'd be pulling down 50 gigs of data over a cell uplink. It can become challenging. So we did end up putting infrastructure on the truck as well. So there's three of the kits you'll see in a minute on the truck. We can deploy our stack on there as needed. And the other thing was we automated everything. So from the WAN router to the switches to our little NFS NAS that's serving up some content data for us to the infrastructure itself. And what's really neat about that is you get a really, really flexible capability in this truck to be able to demonstrate and do all kinds of things. And it's cool. But you do have to have a special parking lot because that 85,000 pounds will wreck a standard parking lot. So, but it was cool to be a part of that. This is my cloud in a box. The case, that travel case, is actually airline carry-on guidelines. So it weighs less than 50 pounds. It's a little hard to see, but there's 4 nodes, which are the horizontal slots, and then there's a small little Intel NUC. And so we can deploy 3 different variations of our stack on here. We can deploy hyper-converged OpenStack and Ceph. We can deploy OpenShift, and OpenShift 4 will be with Ceph as well, hyper-converged. And we can deploy our Red Hat virtualization stack on here. But it's really cool for us to be able to have this carryable kit. I usually actually bring it with me. I didn't today, but it's running at my house. So when it's not traveling with me, it's online and available for people to use and consume as well. We have 3 of these kits we kind of carry and share around. And it's just been neat for us to have a development platform like this. And one thing we did out of this is we developed a bunch of Ansible automation to make it more consumable by a bunch of different people. And the neat part about this is the playbook that deploys the OpenStack and Ceph stack. And this is as simple as it gets, and all of our expertise is built underneath of that. So the very first step is we deploy the first build node, and from there we deploy identity manager so we can do DNS, certificate management, LDAP, and then we deploy our OpenStack installer, and it deploys to the other 4 physical servers. And the rest from there is just all on top. It's all API driven, all Ansible code. It's really cool. But the neat part is we can wrap all of our expertise, all the security baseline we want to apply to it, and all of it's in version control and Git, which is pretty neat. I'm bumping my time. So right there, again, I'm Kevin Jones. Thank you very much for your time today and everybody coming out and seeing us here.